Consider this for a moment. If we could rewind the great cosmic clock, we would have to go back a very, very long time. Not just a few years or even a few million years. We would need to travel back about 4.6 billion years. That is a 4 with a 6 and 8 zeros after it. Back then, there was no Earth. There was no Jupiter. There wasn't even a sun. Instead, floating in a quiet arm of our Milky Way galaxy was an enormous, cold and dark cloud. It wasn't a rain cloud, but a cosmic one, made of gas and dust left over from even older, long-gone stars. This magnificent structure is what scientists call a molecular cloud, or a nebula. This cloud was truly immense, stretching for many light years across the blackness of space. It was mostly made of hydrogen, the simplest and most abundant element in the entire universe. Think of it as the universe's #1 building block. There was also helium, carbon, oxygen, iron, the very same elements that make up you and me. For millions of years, this giant cloud just drifted. But something was about to happen. At the very heart of this spinning disk, the material was becoming incredibly crowded. Gravity was relentlessly pulling more and more gas and dust into this central region. As all that material got squashed together, the pressure went up, way up. And whenever you compress a gas, it heats up. You can feel this yourself when you pump air into a bicycle tire. The pump gets warm. Now imagine that on a cosmic scale. The center of our solar nebula began to get hotter and hotter, glowing with a dull red light. This hot, dense, glowing core was not quite a star yet. It was a baby star, or what astronomers call a protostar. The protostar was the main character in our story, but the disk surrounding it played a huge supporting role. This disk, called an accretion disk, was like a giant cosmic buffet for the growing protostar. Material from the disk continued to swirl inward, spiraling down onto the protostar and adding to its mass. As the protostar ate more material, it grew bigger, denser, and hotter. For about 50 million years, this process continued. The protostar at the center of our solar system was in its infancy, gathering the strength and mass it would need to finally ignite and become the star we know and love today. Meanwhile, farther out in the spinning disk, it was a bit colder. Back at the center of it all, the protostar had become astonishingly dense and hot. The pressure in its core was millions of times greater than the pressure here on Earth's surface. The temperature soared to about 15 million degrees Celsius. That's about 27 million degrees Fahrenheit. At these extreme conditions, the universe's most powerful process was about to begin. The hydrogen atoms, being crushed together with unbelievable force, started to do something incredible. They began to fuse together. This process is called nuclear fusion. It's the engine that powers every star in the sky. Nuclear fusion is like the ultimate atomic collision. In the sun's core, hydrogen nuclei, single protons, were slammed together so violently they overcame their natural repulsion and merged to form helium. When you fuse hydrogen into helium, the final helium atom weighs just a tiny bit less than the hydrogens that made it. That missing mass doesn't vanish. It converts into a tremendous amount of energy. Einstein's equation, E = mc2, explains that conversion. That energy released deep in the sun's core is the source of all the sun's light and heat. The moment fusion began, our protostar was reborn. No longer just a hot ball of gas, it became a true star. A brilliant light erupted from its core, pushing outward with immense force. That outward push of energy balanced the inward pull of gravity that had been squeezing the star. This balance, hydrostatic equilibrium, is what keeps our sun stable. It stopped collapsing and settled into the long, steady middle age of its life. Our sun had been born, and the solar system was bathed in its light for the first time. So, from a vast, dark cloud of gas and dust through a gravitational collapse and the fiery birth of nuclear fusion, our sun came to be. It has now been steadily shining for about 4.6 billion years, a middle-aged star in the prime of its life. It holds 99.8% of all the mass in the entire solar system, and its immense gravity is the anchor that keeps Earth and all the other planets locked in their orbits. Without the sun's gravitational pull, our planet would just fly off into the cold, dark emptiness of interstellar space. The sun is, quite literally, the center of our world and our home in the cosmos. Every single day, the sun provides the energy that makes life on Earth possible. The sunlight that travels 93 million miles to reach us warms our planet, drives our weather patterns, powers the water cycle. But most importantly, plants use this sunlight through a process called photosynthesis. They turn light energy, water, and carbon dioxide into food, forming the very foundation of almost every food chain on our planet. Every meal you eat, every breath you take, can be traced back to the energy produced by our amazing star. The sun is not just a bright light in the sky, it is the lifeblood of our world. By studying the sun, we also learn about the rest of the universe. Scientists use telescopes on the ground and satellites in space to observe its light, its magnetic fields, and the particles it sends our way.